All right, this is a practice question for Module 7. We're given the solubility at a certain temperature. We have tables of values, but they're only the solubility at 25 degrees Celsius. So if we're at a different temperature, we learned back in Module 4, the equilibrium constant is different. It changes as you change temperature. So this is a temperature where the solubility is 0.0116. Part of this module is vocabulary. The solubility tells you how much dissolves. So we've got tin 2 bromide, a little bit of nomenclature here. You've got several sources to figure out what the formula is. You should be familiar with it from Gen Chem 1 and from our lab earlier this semester. But you can Google. You just want to make sure that when you Google, Google's telling you the right thing. So tin Roman numeral 2 is the Sn+2 ion. The bromide ion has a -1 charge. And so tin 2 bromide is SnBr2. So when this dissolves, it forms an equilibrium with the ions that make it up. It is made up of the 2 ions that I listed right up here. And I would get 2 bromide ions because of the stoichiometry. So that is the equilibrium reaction that I'm looking for the KSP of. The K is the equilibrium constant for that particular equilibrium reaction. The equilibrium reaction has this pattern every single time. The stoichiometry will change depending on what the solid is. The solubility tells me in my ice table how much dissolves. So I start with a certain mass. It doesn't matter. This isn't going to end up in my KSP equation. But 0.0116 molarity dissolves, which means starting with 0 and 0, I get 0.0116, and I get 2 times 0.0116. So let me calculate my equilibrium amounts. So m minus this, which again doesn't matter because it doesn't show up in the equilibrium constant expression. And that's 0.0232. I could keep that as 2 times 0.0116 if I wanted. And so the KSP, I encourage you to write this out in a formula first to keep you from making silly mistakes. That's the formula for the KSP. So it's going to be 0.0116, the equilibrium amount of the tin, the equilibrium amount of the bromide ion. So 0.0232, and that's going to be squared. And so my equilibrium constant is 6.243 times 10 to the -6. And to 2 sig figs like shown here, it looks like that is my answer.